Good day, everyone. Hope you are doing well while staying in your home. Let us always remember that this is one way of helping each other so that the virus will spread slowly. And because we are now on pandemic. Now, by the way, what's the difference between pandemic and epidemic? Now, for the information of everybody, the difference between epidemic affects a smaller number of people and it spreads across a wide area or region and it affects more people that you would expect under the normal conditions. While pandemic affects a much larger number of people, so as compared to the epidemic, it spreads across a much wider area or region. It affects most of a certain population. It has higher deaths, higher social disruptions, economic loss, and general hardship. So these are the differences between the two. However, they have also similarities. So what are the similarities? Spreads of disease or infection at an unusual scale, and they are same infectious diseases. So this is how we describe epidemic and pandemic. But by the way, our topic for today is not about epidemic or pandemic, but it is all about Venn diagrams. Okay? Now, what are Venn diagrams or Venn diagram in mathematics? Now, we recall in our previous discussion, we were able to discuss set builder notation, interval notation, roster method. Those are methods to describe sets. Now, here is another one way to describe set. Sets can be represented graphically using Venn diagrams named after the English mathematician John Venn, who introduced their use in 1881. A Venn diagram is a diagram that shows all possible logical relations between a finite collection of different sets. Okay? Now, earlier we described the between pandemic and epidemic using Venn diagram because a Venn diagram is also used to compare and contrast two or more objects, events, people, or concepts. Now, in Venn diagrams, the universal set U, which contains all the objects under consideration, is represented by a rectangle. So we have here universal set, which is denoted by U. A Venn diagram consists of multiple overlapping or non-overlapping closed curves, usually circles, each representing a set. Okay, now to give you more explanation on Venn diagrams, we have here examples, sets, operations, and Venn diagrams. In the first illustration, this is an example of a Venn diagram. It consists of two overlapping sets, but here we label as set A because we consider only the set A, the shaded part here, set A. Now the rectangle, this is the representation of our universal set. Again, our universal set is what? Is represented by a rectangle. Now, in this illustration here, this is A prime. So what do we mean by A prime? A prime in mathematics, this is equal to set of x. So meaning to say x, all the elements in the set A prime such that, so x is in the universal set, but x is not in A, meaning to say all the elements of A prime are the elements in U or in the universal set, but not in A. So that's why the shaded part here, the pink one, this is A prime. So if I say B prime, what is B prime? B prime are or is a set consisting of all elements in the universal set, including here, but not in D. Okay. Now, another example of a Venn diagram is this that consists of non-overlapping two sets. Let's say A and B. As you can see, the two sets do not overlap because this is an example of disjoint sets. So A and B are disjoint sets, meaning to say they have no intersection, or they have no similarities or commonalities. But in this example, we have um, we have set B, which is found in set A, right? So this is what we call subset, meaning B is a subset of A. B is a subset of A, but it doesn't mean that B is equal to A. In this example, B is not equal to A, although B is a subset of A. Specifically, we call this as B as a proper subset of A. Okay? Another example, and the operation is the intersection. We have set A and set B. Now, as you can see, we have two overlapping sets. And for A intersection B, so we read this one as A intersection B, this is equal to the set of X such that X in A and X in B, meaning to say all the elements that are found in A at the same time found in B. Okay, so we read this one as A intersection B or A and B. In this example, we have A union B, meaning we combine all the elements in A and all the elements in B. So this is equal to X, or is a set of X such that X in A or X in B, or we call that as A union B or A or B. Okay, the combination of the set A and the set B. How about this one? This is set difference. A minus B is denoted by this symbol or this notation. This is defined as set of X, set of all the elements which are found in A but not in B. So A not in B. All the elements in A but not in B. So that this is A minus B. So B minus A is the set of X such that X in B but not in A. Okay, this is B minus A, set difference. Okay, so these are examples of set operations using Venn diagrams. Now, to give you an explanation to really explain the topic, we have an example or examples. First example, draw a Venn diagram that represents V, the set of vowels in the English alphabet. So we are given set V, again, the set of vowels in the English alphabet. So the first thing to do is to create a universal set represented by a rectangle. Now, suppose this is our set V, okay, that consists of what? Consists of all vowels in the English alphabet. So what are the vowel letters in the English alphabet? By the way, all the letters in the English alphabet consider as the elements in the universal set, while V is just a subset of the universal set. It's the subset of all the English alphabet letters. Okay, so what are the elements of V? The elements of V are the vowel letters A, E, I, O, and U, or A, E, O, U. These are the elements in the set V. Okay, so this is one way of describing set V using Venn diagram. Another example, suppose we are given these sets. We have the universal set U, which is a set of 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have set A, which is consists of 1, 2, 3, and 4. Well, set B is equal to the set of 3, 4, 5, and 6. Now use Venn diagram to show A union B, A intersection B, A minus B, and A prime. So first, we must get the A union B. Again, the concept of A union B is to combine all the elements of A to the elements of B. So we make a universal set. Again, what is a universal set? It consists of all the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the elements in U 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what is A union B? We are given the set A, 1, 2, 3, 4. Okay, so this is now our Venn diagram for A union B. As you can see, this A here consists of 1, 2, 3, and 4, and set B consists of 3, 4, 5, and 6. So if we are going to combine using this Venn diagram, this is um, what is supposed to be. Okay, so this is now the A union B using the Venn diagram. How about A intersection B? For the A intersection B, we have to consider all the elements that are found in A and also found in B. So universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the elements in the universal set. Now, this is the intersection of A and B. So what are the elements in the intersection? The 3 and 4, because 3 and 4 is found in A and 3 and 4 is also found in B. So this is how we describe the intersection using the Venn diagram. How about A minus B? Again, A minus B, all the elements in A but not in B. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the elements in the universal set. So A minus B, this is the Venn diagram for A minus B. All the elements in A but not in B. So if we are asked what are the elements of A minus B, the elements of A minus B is 1 and 2 only. Okay, how about A prime? Again, A prime is a set consisting of all the elements in the universal set but not in A. So what are the elements in A prime? So again, we have the elements in the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have set A, set B. Okay, what is A prime? A prime, this is A prime, the entire pink region. Okay, A prime again is a set consisting of all the elements in the universal set but not in A. So what are the elements in A prime? The elements in A prime are 5, 6, 9, 8, and 7. So these are the Venn diagrams and also the set operations that we are discussing. Okay, so hope you like this video and don't forget to share what you learned from this video. Thank you and God bless.